Hello again, everyone. Welcome to part 2 of our video on the distance and midpoint formula. This video is all about the midpoint formula. So we're going to again start this video by looking at a number line. So we're going to look at a number line where we have a segment AB. So A is at -6, B is located at 2. But instead of in part 1 where I asked you to find the length of that segment AB, I'm now asking you to figure out where is the location of the midpoint. So if I was to draw a point in the middle of this segment, exactly where would that point be? So if we go we'll go back to old school, right? We liked our bunny hop in the last video. So let's take a look. If we're going to be looking for the midpoint, that means however many spaces we're going to be moving on one side of our line endpoint, I need to also move to the other. So I just moved 1 on both sides, 2 on both sides, 3 on both sides, and if I move 4 on both sides, that tells me that the location of the midpoint is at -2. So again, we've progressed a little bit since the bunny hop. So if we're going to do this more mathematically, we want to figure out the middle. We also call that the average of two numbers. So in order to figure out an average, we have to add up our 2 points. So we're going to add -6 and 2. And we're going to divide that by 2. To find an average, you add up your 2 values, divide by 2 in this case because we have 2 values. So if we add that together, we end up with -4 over 2, which leads us to the conclusion of -2, which is what we had gotten before with our bunny hops, as the location of our midpoint for this segment. All right, so let's progress a little bit. That's on a number line here. So add up the 2 values, divide by 2. If we move to a coordinate plane, it's really going to be the exact same idea to find the midpoint. But we're going to have to look at not only averaging the x values, but also averaging the y values, right? We're going, instead of 1 dimension along a number line, we're going now in 2 dimensions. So we're going to have to do the averaging twice, 1 for x's and 1 for y's. So the way we write out our formula for that is x1 plus x2, right? We're going to average our x's, so x1 plus x2 over 2, comma, because our answer is going to be a coordinate, it's going to have an x value, comma, a y value. And then we're going to do the same thing for y. So we're going to average our y's, y1 plus y2, and divide that by 2. So for us, if we're looking at AB, A is located at -3, 0. B is located at 0, 4. All right, so we know from before that we can go ahead and label our points. So we can call this one x1 and y1. Nope, it does not make a difference which one you label as the first coordinate, which one you label as the second coordinate. Okay, and then let's plug into the formula. So we need to add up our x values. So -3 plus 0. And we can divide that by 2, comma, add up our y values. 0 plus 4, and divide that by 2. And then let's simplify. -3 plus 0 is -3, comma, 0 plus 4 is 4. The last step, -3 over 2 is the same thing as -1.5. You can leave it as a fraction if you would like, or you can leave it as a decimal. 4 divided by 2 is 2. And if we look to our segment, if we were going to plot that value, -1.5, comma 2 is going to be just about here. And visually, that makes sense. That looks like it is approximately in the middle of that segment. So if we put M to represent midpoint as the name of that point, right, we would know that that is the exact location of the midpoint of segment AB. So your turn. The midpoint formula again is written out over to the right-hand side here. So go ahead, pause the video, and see if you can find the location of the midpoint of a segment FG given the endpoints for F and G written on your page. So f is going to be my x1 comma my y1. I'm going to call g my x2 comma my y2. And then let's go ahead. We need to make sure our answer is written as a coordinate because that's what we're finding. A midpoint is a point. It's a location in space, so we need to write it as such. So we have to add up our x's. -9 plus -5. Divide that by 2. And then add up our y's. 2 plus -10. Divide that by 2. When we simplify, -9 plus -5 is going to give us -14. 2 plus -10 will be -8. Again, we've got to divide both of them by 2. So it looks like we get -7, comma, -4 as the location of our midpoint. And we could think about it logically. It makes sense. If we go from -5 and we add 2, we get -7. If we do -5, if we go 2 more from the -7, we end up at -9. So because we can go the same distance from the one endpoint to the midpoint is the same length as the midpoint to the other endpoint, that means it has to be in the middle. If we do the same concept with the y values, -10 to get to -4 is a distance of 6. If we add 6 to the -4, we end up at the other endpoint, which is +2. So logically, it is going to make sense to us that our midpoint here is going to be at a location of -7, comma, -4. So what if we change this type of problem? Instead of 2 endpoints or asking for a midpoint, what if I gave you an endpoint and the midpoint and asked you to find the location of the other endpoint? So we'd have to think about that on a coordinate plane, right? We would have to be able to figure out, well, how do we get, kind of like what I did in the last example, how do we get from one endpoint to the midpoint and then do the exact same thing again to get from the midpoint to where the other endpoint will be? So let's take a look. Where is the endpoint of R, of a segment PR, if P is located at -5, 2, and the midpoint is located at -1, -3. So let's do this visually first. We can plot the points, -5, 2. So I'll call that P. And then M is going to be our midpoint at -1, -3. So visually, if we're trying to find a location for R, that means that we would expect R is going to be somewhere down here because it has to be the end point of the segment, right? We have this segment that's going along this path where M is the midpoint. We would expect that R then is going to be somewhere in this circled area down here. So let's figure out, how did we get from P to M? I'm going to write the 2 points over to the side, P and M. P is located at -5, 2. M is located at -1, -3. And I really want to figure out where R is. So I'm just going to set it up, but I'll leave it blank. So let's figure out. If we look at just the X values to get from P to M, the difference in the X values, we had to add 4. So if we add 4 again, so P, M to R now, if we add 4 again, if we add 4 to -1, we get 3. Let's do it, same idea now to the Y values. To get from 2 to -3, we would subtract 5. If we do that again, -3 subtract 5 is going to give us -8. So that would mean to us then that our location for the other endpoint, r, is going to be located at 3, -8. Let's plot it on the coordinate plane that we have and see how close are we to that circled region that we had from the beginning. So if I plot 3, -8, I'm going to get a point down here. I could name it R. And then if I extend my segment that I was working on, does it still look like M is the midpoint then of that segment PR? It really does. So it looks like we're good, right? We are good. We found the location of the other endpoint of a segment. So did we really need the coordinate plane in order to answer this question? No. All we really needed to do is to line up our endpoint, our midpoint, and our other endpoint. And then we were able to figure out the difference in the x values and continue that pattern, find the difference in the y values, and continue that pattern. So if you would like to go ahead and pause the video and try this one on your own, go right ahead. So we're looking at an endpoint of C, a midpoint of A, and the other endpoint is T. So we're given that T is at a location of -1, 9. We're given that the midpoint A is located at a point of 7, 4. And we need to figure out where C is located. So let's take a look. If I start at T, how do I get from -1 to 7? What would I have to do? The difference between -1 and 7 is going to be adding 8. So if I do the same thing, if I'm at 7 and I add 8, I'm going to get 15. Let's do it again for the y's. If I start at 9 and move to 4, that means I subtracted 5. If I start at 4 and again subtract 5, I'm going to end up at -1. So that means my other endpoint is located at 15, -1. So we just saw a couple of different examples there of how to find the location of a midpoint on a coordinate plane given 2 endpoints. And we've also looked at a couple of examples where I've given you the location of the midpoint and one endpoint and asked you to find the other endpoint. So just be careful with these types of problems. They look very similar to one another, but they are very different in how you solve for them. So just make sure that you're reading the question carefully. Are you given 2 endpoints and asked for a midpoint, or are you given an endpoint and a midpoint and asked to find the other endpoint? Thanks again for watching.